Hello guys, let me give introduction for control system. Of course, in our control system also, once again we are going to discuss about something new, right? Already we are discussing about network analysis, electrical machines are there, power system is there. Our electrical engineering, we are doing something in our electrical engineering courses, right? And apart from this, what we are going to do in our control system especially, right? When the moment we are discussing about control system, stability is the first term is coming to the picture, right? So what do we mean by stability and what we are going to do in our control system, right? Of course, in our control system also, I am going to take a set of block, a whole system, right? A whole system which are always linear and time invariant, right? A whole system will be putting, I am going to put into a single blocks, right? Or single block we are going to merge, right? Let me take a power system, right? Like a power system in the sense, assume I have a set of zone. In that zone, all the elements are linear and they are not varying with respect to time. So that elements are called time invariant elements, right? So whichever the elements that are time invariant that are put into the single block, right? Or block now we are going to analyze the fundamental properties of that single system, right? So in our control system, especially what I am going to do, we are going to check the stability of the higher order systems, right? The first thing is, even in our algebraic equations also, we understood some basic things. Enna basic things la நம்ம learn பண்ணிருப்போம் அப்படினா, like third order equations வரைக்கும் வரும்போது, we have some tools to analyze the system stability, or somehow we can predict the characteristics of the system up to third order or fourth, fifth also, okay, with some trial and error procedure we can do. So when the moment your higher order systems are fall in place, when the moment we are supposed to calculate the value of 7th order systems or 8th order system, in such cases we are unable to predict the natural stability of the system. So in control system we are going to use some mathematical tool. That mathematical tools will going to simply helping us to get the grip with the system, to identify the stability of the system. So what I am going to do, I am suggesting you all in control system what we are going to do. That is, you have to get the clear idea, sir. As per my suggestion, right, you have to register from this moment onwards. In control system we are going to discuss about something new. That something new things will going to help us to identify the steady state and the transient behavior of the system, right? Of course, we are going to travel along with the higher order algebraic equations. Even in higher order algebraic equations also we can guess whether the system is stable or unstable. Such kind of mathematical tools are there here. That is called Routh-Hurwitz criteria, or already you people might be heard about these things, right? So in the same way, we are going to use some mathematical tool. First I am going to take Laplace transformation, right? And then with the help of the Laplace transformation, we are going to take our entire universe wherever we have the systems, right? We can observe, see, even in our machines also, first what we are doing, actually we are designing the electrical machines. Even in a power system, after designing all the components, I have to control the equipment, I have to test the stability of the equipment externally, I have to test the stability of the equipment, and I should know at which point your system is going to be controllable, at which point your system is going to be uncontrollable, right? So everything we can predict, right? So control system is not a separate topic, and don't think that suppose a control system is not our syllabus, it is not our electrical engineering, right? So control system also going to be the heart of or part of the electrical engineering only, because after designing the entire block of the power system, now you should stand outside. With the help of a simple control system mathematical tool, you can guess whether the system is stable or unstable, right? So you can go wherever you can go, even in our power system, electrical machines, in our physical world, wherever you go, each and every component can be treated as a system only, right? That system may have sustained what I can say specific task. Whether that specific task can be controllable or not. If a system can be controllable, right, from the observation I understood I am a system, right? I am a system and I am controlling my components. So I am simply called what? Control system. So wherever you go in our physical world, if a component is doing some specific task and that component will be controlled by some person, that is simply called a control system. That's all. There are no more things to do about the control system, right? So what is the conclusion here? Control system is not a separate topic and it is not a separate subject. It is also one part of our core. It is also one part of our art, right? So we should take and we should control. We can see after designing the alternators, after designing the power systems, everything is ready now, right? Pakka, right? Now what you have to do, you should control the systems. You should control, you have to know whether the system will be stable or unstable, in which zone, in which point, up to which point your system will be stable. After getting all those points you should control, right? For our alternators, usually what we are trying to do, under stable zone. Under stable zone in our power system also, the value of del will be lies between 0 to 90. If you go beyond 90, system will become unstable, right? So to maintain my system is the stable one, we are trying to restrict the value of del. So we are controlling, so their control system will fall in place. So there is no, in this world, there is no components will exist without the controllability. Some components are there that will be simply called systems, right? But if I keep over the control, right? If I keep some control over that system, that is simply called the control system. That's all, right? Now, which are the things that we are going to discuss in this introduction part? I am going to discuss with you all which are the topics that are going to discuss in our control system, which are the topics that are most important in our exam point of view. And second thing, you should realize the physical meanings of each and every part that we are going to discuss in our control system, right? So physically in the sense, so the first thing is we are going to discuss about the basics. Sir, what do we mean by control system, right? And which mathematical tool will going to play in our control system? Especially, of course, we are going to discuss about Laplace transformation. Frankly speaking, Laplace domain or Laplace transformation will going to play a role with our control system. Without Laplace, you cannot play. Of course, there will be some reasons why we are going with the Laplace transform at all. The reason is, if you go with the Laplace transformation, I should analyze whenever you are taking a person like you are trying to guess me. You are trying to guess me. You are trying to guess my properties, right? So when the moment you are what I can say, first time நம்ம ரெண்டு பேரும் மீட் பண்ணோம்னு வெச்சுக்கோங்க, right? So you people are meeting at the first time. So at the first time நீங்க என்ன மீட் பண்ணும்போது என்ன தெரியாது, you cannot guess me. You cannot guess about my characteristics. You cannot guess about my knowledge, right? You cannot guess about my way of teaching. So nothing you know, right? You come to know when the moment you are meeting at the first time. Then what will happen later, after started attending our classes slowly, gradually you will come to know, okay, he is the way of, that is the way of teaching, right? So that is how he is attracting us. So slowly in the sense, after it may take some 1 month or 30 days or like what I can say 1.5 month or some particular duration will be there to reach steady state. In the sense that region is called transient region. Sir, I am taking 40 days to understand. You people are taking 40 days to understand my actual characteristics, actual way of teaching, actual way of attracting you all, right? So actual way of my actual knowledge. So for that you people are spending some 45 days. That is called a transient zone. So after that what will happen? After some 45 days or 50 days you will guess about my characteristics and my way of teaching and how I will behave in each and everything you will guess, right? So that is called a steady state zone. So here simply we can say in our control system Laplace transformation will going to play a role with us and it will going to help us to guess, right? To identify the transient behavior and the steady state behavior of the system. That is why we are going with the Laplace transformation. So Laplace transformation is a mathematical tool. That mathematical tool will going to play with each and every systems such that in each and every systems the transient and the steady state behavior of the system can be predicted exactly. That is why we are going with the Laplace. That is the main reason actually, right? Okay, fine. So we are going to, in basics, first we have to introduce, that is we should talk about the Laplace transformation, and then we are going to design the mathematical and electrical modeling of our systems. Like if I have a mechanical system, how that mechanical system will be converted into electrical domain, and then how beautifully, see, the beauty of the control system is I have a mechanical system here. I am unable to predict the behavior of the system directly when the moment I am looking at the mechanical system. But in control system, you know one thing, right? In control system, we can convert that system from mechanical domain to electrical domain, right? So once it will be converted, then we have a lot of components here. Laplace transformations are the input signals. With the help of the signals, standard signals that we are going to use here, after converting that system from mechanical domain to electrical domain, you will be able to identify the characteristics of the system. You can guess whether the system will be stable or unstable, right? Whether we can connect the system with the mechanical domain to electrical domain or not. At which point it is going to be controlled. At which point it is going to lose its controls. So everything we can guess. So for that we are going to design. The first primary task of us is we should design the mathematical modeling of our control system. Of course, that is the way how we are going to look at our control system, right? So mathematical modeling will going to play a role here, right? So first we should learn, sir, how to design a system mechanically, how to design a system electrically, how to interconnect the systems from mechanical domain to electrical domain. Once it is over, next once it is be converted, then in the domain, right, after converting the systems into electrical domain, or you can also keep it over mechanical domain, wherever you want you can keep it, right? So once it will be placed, then that is actually what I am going to do. We are going to form, that is we are going to bring the mathematical differential equations from that electrical domain to mechanical domain or mechanical domain to electrical domain, right? Convert பண்ணதுக்கு அப்புறம் from that mathematical modeling we are going to bring the differential equations. Of course, once we bring the differential equations, what is our next task? Just with the help of the mathematical tool, that is our Laplace transformation, we are going to obtain or we are going to analyze the properties of the system. We are going to check whether the system is stable or unstable, right? Adoda system oda order எப்படி வேணாலும் இருக்கலாம், right? So Laplace transformation will going to play a role with us, right? And it will going to test the stability of the system at the initial stage. What is the behavior of the system? At the final stage, what is the behavior of the system? Of course, in our control system, you know one more thing. Control system பொறுத்த வரைக்கும் என்ன அப்படினா, it is like us, right? When the moment you are like what I can say, this is the first class for you in our control system, this is the first class for you. Of course you did not guess me, இதுக்கு முன்னாடி என்ன பத்தி உங்களுக்கு எதுவுமே தெரியாது. But in control system, you know one thing, from the moment where you are starting my lecture, from this moment onwards you can guess me, and then you can analyze, you can test, right? இதுக்கு அப்புறம் நீங்க என்ன பண்ணிக்கலாம் அப்படினா, you can test my experience, like இந்த person வந்து எப்படி எப்படி எல்லாம் பிஹேவ் பண்ணுவாரு. Without knowing the fast behavior of me, you are going to guess from this moment onwards. When the moment you are entering, that is the initial point. From that initial point up to infinity, we are going to travel along with me. You people are going to travel along with me. So, in our beauty, in the beauty of the control system, we people are not keeping our concentration with the past response. We are only keeping our concentration. Okay, this is the present moment. From this moment onwards, I am going to test you. I am going to guess you. I am going to use you. I am going to check your ability. So whichever the thing that you are going to do, we are going to start at t equal to 0 only. Past things cannot be considered. That is, we are not going to consider actually, right? So appo nama enna pannona, present moment வந்து we are going to travel with our system to the future. Clear? That is the beauty. So Laplace, after the differential equation கொண்டு வந்ததுக்கு அப்புறம் next what we are going to do, of course we are going to, that is அந்த differential equation கொண்டு வரோம். Of course அது வந்ததுக்கு அப்புறம் with the help of Laplace transformation you can play with that system, right? Of course some other things are there. Sir, now I have a big system, I have a very big system, right? In that very big system I have like 10 systems are there, some 20 systems are there, right? Now with the help of block diagram reduction technique, that's so 20 system components whichever interconnected, like in our power system there are thousands and thousands of alternators are connected together with my loads, right? Now I would like to connect them all together. I would like to, that is whichever the terms, right? என்னால எவ்வளவு ரெடியூஸ் பண்ண முடியுமோ அவ்வளவு சிங்கிளா வந்து நம்ம ரெடியூஸ் பண்ணி some mathematical tools will going to play a role with our block diagram reduction technique. With that mathematical tools we are going to convert the properties. That is, we are going to, what I can say, a big system will be converted into a single block. In that single block we are going to analyze this system. So that is the beauty of the control system. You no need to travel, sir. There is a big system with 100 components are there, sir. I am unable to predict. Can I able to predict the structure of the system? Of course you can do. That 100 blocks can be merged into the single block. Then you can analyze the properties. Of course, signal flow graph and block diagram reduction techniques are going to play the same thing. Comparatively, signal flow graph will directly deal with the systems. If 100 components are there, directly we can connect. You can bring some branches and we can play with the systems. You can travel with the systems. With some reduction techniques are there. Of course, we will see later, right? So next we are going to see, that is, we are going to discuss about the beautiful concept that is called block diagram reduction technique and the signal flow graph. That is the next topic, right? Of course, in the next stage, what we are going to do, as I said, Laplace transformation will going to play a role in our system. It will going to test the what I can say, transient behavior of the system and the steady state behavior of the system. So next we are going to introduce two domains here. One is called a time domain analysis and another one is called frequency domain analysis, right? Of course, up to a certain point we are going to travel in time domain. We are going to test the properties of the system in time domain itself. Some systems are there which are all going to be tested in the frequency domain, right? We will see how to test a system in time domain, how to guess the characteristics and behavior of the system up to second order and time domain analysis, right? If my system will be in higher order, then how Rauther's criteria will going to play a role with the higher order systems. We should check the stability of the systems in time domain, or if you want to travel along with some system stability from one point to another point, Rauther's criteria simply will tell you whether the system will be stable or unstable, right? If you want to make this system will become a stable one, unstable வந்து நீங்க ஸ்டேபிளா மாத்தணும் அப்படினா ஒரு பாயிண்ட்ல இருந்து இன்னொரு பாயிண்ட்க்கு நீங்க எவ்வளவு தூரம் வந்து ஒரு சிஸ்டமோட கேரக்டரிஸ்டிக்ஸை சேஞ்ச் பண்ணா சிஸ்டம் வந்து ஸ்டேபிளா மாறும், எந்த ஜோன்ல அந்த சிஸ்டம் வந்து அன்ஸ்டேபிளா இருக்கும், இந்த மாதிரி ஒவ்வொரு பாயிண்ட பத்தி நம்ம பேசணும் அப்படினா of course we are going to travel along with the root locus diagram. You might be heard these things, right? So Rauther's criteria also will going to deal with the stability. Root locus diagram also will going to deal with the stability. But what is the difference between them? That Rauther's criteria will be the part of the root locus. I can say like this because Rauther's criteria will deal with whether it will tell whether the system will be stable or unstable. But it won't help us to make the unstable system as a stable one. But in root locus we can play, we can push the pole. If you are sitting here, because of you I am unstable, let me push you there, so your system will become stable. That cases could be possible in our root locus. We will see. And apart from this, we are going to discuss about some type of systems are there, and they are going to be analyzed in the frequency domain. For that we are going to use polar plot and Nyquist plot, because polar and Nyquist are not they are not separate theorems. We will see they are actually mingled together. We will see how to analyze them at all, right? Separate theorem also there, but I will teach you. There are some beautiful ways to understand them, right? And then we are going to discuss about like body plot. Body plot will going to play a role with our systems, right? With some different units, we are going to analyze the body plot with some different characteristics. We will see later, right? And then we are going to discuss about that is compensators, right? Compensators and the controllers, right? They are how your compensators and the controllers are going to play a role with our system. Guys, once again I am repeating, control system is not a separate topic. It is not a separate subject. You should understand, right? Controllers and the compensators, how they are going to play a role with our systems, right? How a system, right? Or a system, we should see, simply you can say controllers, compensators in the sense, like our power system, we are using synchronous motor as a synchronous condenser. That synchronous condenser simply supply the reactive power for our system such that power factor can be controlled. Yes or no? So that can be act as a controller or a compensator. That is the meaning of the controller, right? So don't think that the control system is a separate topic. It's a heart of, it is the art, or it is a part of your heart in our core, right? So it is also merged with our system only. It is not a separate subject. You should understand, right? How we are going to simply play with the mathematical tool, some basic standard systems. This is called a controller, this is called a controller, this is called a compensator. Especially we are not going to, there is physical interruptions in the sense, in power system, electrical machines and all, we are especially we are selecting a specific controllable machines, and we are keeping our concentration with that specific machine. But in control system, generally worldwide, whichever the systems are there, that will be generalized. We are testing that system will be stable or unstable, such that worldwide, whichever the terms are there, whichever the terms are controller here, whichever the terms are acting as a controller in our electrical domain, mechanical domain, wherever you are going, whichever the machines that you are taking, right? So it will be generalized. Controller compensators are generalizing, right? So in our power system, we are going to keep our concentration. Once we learn the tools in our control system, and then we will get the beautiful idea. Wherever I am going to travel along with the power system or control system, like what I can say, electrical machines, power electronics, wherever you are controlling the equipment, that is nothing but our control system only. It's going to play. Wherever you are compensating something, right? If ஒரு person வந்து behavior வந்து நல்லா இல்ல, அவரோட behavior வந்து கொஞ்சம் பேடா இருக்குனா அந்த behavior மாத்துறதுக்காக we are using one compensator. That is nothing but our compensators and controllers in our control system. So that is not a separate topic. You have to understand the beauty of the control system because it is directly related with our physical world. I will tell you each and every topic you will get the sense things, right? Actually how your windings or controls are going to play a role with our systems, and even in our physical world also we will interrupt, right? Okay, next finally we are going to discuss about the advanced topic that is called state space analysis, right? In state space analysis we are going to discuss about past also. So up to now, I said, I only told you we are going to consider only initial conditions. We are going to start from this moment onwards, and we are going to travel along with your system towards the future. So in our state space analysis, I am also going to guess the past response, and I am also going to test the system. Okay, this is the starting point. Before that, how that system was being. Now how that system is going to be. In future, how that system can be, right? How that system will going to behave, right? So everything can be tested in our what I can say state space analysis, right? So these are the things that is completely we are going to discuss in our control system. Keep your concentration with us, right? I hope you all are getting the overview of our control system. It is not a separate part. It is the heart of our, or it is the part of our heart. That is heart in the sense our core, like our electrical machines, power electronics, power system. It is going to measure with that, and at last you can finalize, right? The entire system is nothing but control system only, right? But in control system we are going to some restrictions, right? That system will be assumed to be linear, that system will be assumed to be time invariant, and then we are going to apply our Laplace conditions with some initial past responses are neglected, such that with some restrictions we are going to bring the stability of the system, right? So rest of things we will see in the next lecture. We are going to give, that is first I would like to teach, that is we have to look at Laplace transformation, because Laplace transformation is very important. Without knowing the Laplace transformation, of course we are not going to explain, that is we are not going to look at the Laplace transformation in detail. Whichever things that are very important in our control system system point of view, first we will deal with that one. Later, in our signals and system, we will see the in detailed explanations. You can see in our signals and system course, what is Laplace transformation, what is bilateral, unilateral, where we are going to play with the Laplace transformation, difference between Fourier, Laplace, everything we will see, right, in our signals and system. Okay, so with this, I am completing this lecture. In the next lecture, we will see, or we will see the in detailed explanations of our, what I can say, Laplace transformation, right. So thank you all.